Right. So we're going to continue and work on solving our functions and our systems of equations. So our first group problem number 36, solve each system of equations. There's an A, B, C, and D, and I just kind of split it up on some different slides. And they want us to do this without graphing. So for each one, explain what the solution or the lack of thereof, and it tells you about the graph of each of these. Right? So for A, if we looked at our top equation, oh, I didn't want to use that guy. I wanted this guy, yep. If I look at my top equation and if I were to graph it, I would get a line. If I graph the bottom one, I'm going to get a line. So what are the possibilities? Either these two lines are going to intersect, right? And they could intersect at a point, right? What else could happen?
They could just not.
Or they could just not touch, right? So we're either going to find a solution, and that solution is going to be a point, or we're going to find no solution because our two lines are going to be parallel.
So
right?
if it's no solution, then it's just no solution.
It's no solution, right? Because the lines are going to be parallel, right? So how are we going to do that without graphing these guys? Oh, set them equal to each other? We can do that because we were just talking about that, right? We know that our variables are y is going to equal y, x is going to equal x. So if it kind of helps a little bit, write that y equals y to begin with. Okay. And what does y equal? Well, one of them equals negative 3x plus 5. And what's the other one equal? Negative 3x minus 1. Right? What are we going to do to solve this guy for x? What do you want to do first? Add 1. Add 1 to both sides. I can do that. We're going to get what? Negative 3x plus 6 equals negative 3x. And then what do we got to do?
Would you add 3 again, like add 3
Add
to
3
both
to
sides?
3x and then you get 0 equals
Yeah, we'd have to add 3 x's, right? Because that's how many x's we got? Yep. So add 3x to both sides. And what do we get?
6 equals 0.
6 equals 0. What does that mean?
No solution.
Yeah. Does 6 ever equal 0?
No.
No, so it makes absolutely no sense. Now granted, if I came up with a solution and I had 6 equals 6, does 6 equal 6?
Yeah.
Yeah, it always equals 6.
All real numbers, right?
Right, well, yeah, so it'd be all numbers. So ultimately what that's telling you is they gave you the exact same line and those two lines are right on top of each other. So if you get 6 equals 6. So this one would be no solution. Because we know that 6 does not equal 0. Is there any other way we could have looked at this problem to know that we had no solution?
Yeah,
What's the other thing we could have done?
I don't know.
You don't know.
I just think there's no way.
Wait.
Well, no, because you could have just looked at it and said negative 3x and negative 3x.
Yeah, what's that negative 3 tell us in this problem?
That they're both on the same part of the line. It's the slope.
It's the slope. Yep, that is exactly it. That's the slope of the line, right? And if our slopes are exactly the same, what does that tell us?
They're on top of each other. They're like parallel.
Yeah, they're going to be parallel. And are parallel lines ever going to intersect?
No.
Nope. So we automatically, if we were to just look at the equations and realize that it's written in that slope-intercept form and that our slope was negative 3 for both of those, we would know that those two lines are parallel, and we know parallel lines are never going to intersect, right? And then if we wanted to graph it, we could throw it into a graphing calculator or we could graph it by hand and we would see that those two lines are parallel as well. Not too bad for A. I went ahead and skipped B and thought we'd just work on C and D because I have another problem to do after this. So just trying to give you guys some more examples. So let's look at C. And we can't put this into our graphing calculator because it told us we couldn't. So we have to try and figure out how to do this algebraically. Well, it is and it isn't. Come on now. You don't always have a fancy dancy calculator with you.
Yeah, you do.
right? You
Okay,
know?
well, I won't always be walking around doing algebra 2 problems.
Oh, yes, you will. You always will be figuring these out in your life. Yeah. All right. Anybody got any ideas?
I don't understand why it's squared.
It just wants to square it.
So then couldn't you just set them against each other and say x squared? No.
Or-
Or
Well,
y squared
yeah.
equals x,
Yeah. Do we know what x equals?
y squared.
Yep. So you can do this one a couple different ways. If you want to look at like this x squared, right? Or that x, sorry. That x is the same thing as this x, right? So could you substitute y squared in there? You could, right? That's one way to do it, absolutely, right? Or you could almost do it the other way as well, right? We know what y equals. So you could take all of this, which is your y, and you could plug it in for your y and then have to square it. So it's kind of a personal preference. Either you're going to substitute x, one of the x's, into the other equation, or you're going to take y and substitute it into the other equation. Yes?
You still can't just solve it.
So if you took like the y or the x minus 2 and put it in like where the y squared is,
Yep.
would you square the x minus 2?
Yeah, yep. So it's,
oh, okay.
yep, we can do it that way. Let's do it that way, right? So we're going to take this as our y, right? And we're going to plug it in for our y here. So originally we had that y squared equals x, but what are we going to put in for y now? X minus 2, right? And the only thing you're substituting is for the y, and the rest has got to stay the same. So you still need the square, and that's going to equal x. All right? So I think we need a little practice on multiplying squares out. So we're going to do it that way, right? How many people thinks it's going to be like x squared plus 4? Good job, right? So if I'm squaring it, that's the same thing as x minus 2 times x minus 2, right? That's still going to equal x. We can't leave the rest of it. So now you have two options. Some of you guys might be really good at using the distributive property and making sure you're sharing with everybody. Or the other thing we can do is we can do that area model, right? And we got our x minus 2, and we have our x minus 2. And then we're just going to multiply those through. X times x is going to give us x squared minus 2x minus 2x and a positive 4. Everybody good on doing the area model? Yep. So then we're just going to combine like terms. What do we get? X squared. How many x's do we have?
Negative 4.
Yep, you got negative 4 x's. Right? Plus 4 equals x. So it looks to me like we got a, what's that Q word? Quadratic. Yep. So easiest way for us to solve quadratics is to get everything on one side where it's equal to 0, and then you can either try and factor it or use that quadratic formula, right? So I think I got to subtract my x over first. You guys agree? So what do we get? X squared minus 5x plus 4 equals 0. Since we got a quadratic, we know that we're going to come down to two factors, and those two factors are still going to equal 0. So we just got to figure out what those two factors are. So we can either go straight into our parentheses, or if we still need to, we can do the area model. So we want to do parentheses or area? Want to do area? I'm good with area. Oh. So we got our little box. Right. So we're taking these 3 terms and we're making them into 4 terms. So we always leave our x squared the way that it is, our first term. We always leave our last one the way that it is in that last box. And so we're trying to figure out how to separate that x, that negative 5x. We want to split those into two different like little x's, right? So to figure that out, we're going to do a times c is positive 4. So to get a positive number when it comes to multiplying, they can either be a positive positive, or they could be a, how else are you going to get a positive number to multiply? A negative and a negative, right? So if it's going to be positive, the sign's got to be the same. And we have to get to a negative 5, so guess what that's going to tell us? They're both going to be negative. Yep. So now we just got to figure out. So to get to 4, I can either do 1 times 4, or I can do 2 times 2. But when I combine them, I have to get a 4. Or sorry, my bad, I have to get a 5. Which one's going to give me 5? 1 and 4 or 2 and 2? 1 and 4, right? So we know this guy's not going to work. And since the signs are the same, it doesn't matter where we put the 1 or where we put the 4, right? Because they're both negative. Now we're going to pull out that common factor, right? What are we going to get, an x? Since we're leading with the negative, we're going to pull that negative 1 out. And since we have an x, and then we're going to leading with that negative 4. Right. So x plus, whoops, I am a dork. X minus 1 and x minus 4. Right? Zero property rule tells us that one of these or the other has to equal 0. So we're going to get what? X equals 1 or x equals 4. Oh boy. Oops, sorry guys. There you go. Not too shabby?
That one was just weird.
Weird?
It was just too much.
Too much?
Yeah.
Well, you're going to get some more. Oop. Alright. So let's look at our D over there on the right side. Alright. So this one, they just kind of mixed it all up for us. And so we know we can't graph it. We have to do it using some algebra. So what do we know from that little problem? What do we see? Yes.
You can substitute, like you can substitute a y for 2x minus 5 is y equals.
Yep, absolutely. Yep. Because they already solved it for one of the variables. They solved it for y, right? And oh, maybe. And this y is the same as that y. So we're going to take and put that in there for the y, right? So we originally started with 4x minus 2y equals 10. But we're going to make that substitution into the y, so everything else is going to stay the same. So we still got our 4x minus our 2. The only thing we're changing is the y. So we're, oh boy. Yep. So I'm going to throw my y in parentheses, okay, which is 2x minus 5. And that whole entire thing's still going to equal 10. Then now I think is this algebra 1 are we at now? I think so, right?
We should distribute the negative 2.
Absolutely.
X and the negative 5.
Yep, and what are we going to get? 4x minus 4x plus 10 equals 10. Did you guys get the same thing? Yep. Now what are we going to do?
Quadratic thing.
What was that?
Quadratic thingy or no?
Well, quadratics, if we have a quadratic, and a quadratic would be when our exponent is 2, right? Maybe we could combine some like terms.
You can combine the 4x's.
Yep. And what are you going to get? What's 4x minus 4x?
Would it just be 0?
0. So what are we left with? 10 equals 10 equals 10. Is that true? Yeah. Is it always true?
Yes.
Yep. So guess what they gave us? They gave us the same exact line written 2 different ways. Yep. Very nice. All right. Oops. So we have all solutions, so we have infinitely many solutions. Because a line is made up of all of these points, and a line goes on and on forever, so you have infinitely many solutions, right? Not too bad?
Sorry.
Starting to sink in a little bit? All right. One more for you. One more fancy, crazy one, right? And it's going to get a little nasty, but if we take it slow, I'm telling you, it'll all just be like, what? Right? So again, they don't want us to be graphing these. They want us to be able to try and do this using some algebra, right? If we were to graph these, what do you think you might get?
I just can't even see the number two.
Anybody got any ideas what this guy might give you? The second one? Not a line.
A curve.
A curve, a
Quadratic facing down.
Yeah. So if it's squared, the quadratics always give us those parabolas, those U shapes. And since that's a positive, it's actually going to be an upward turning U.
Well,
Yeah. Anybody got any guesses on the first one, what the first one might look like?
A line.
Not a line.
it's x and y equals 25.
A circle.
A circle. It is. Yep. So this guy's going to give us a circle.
How do you know that?
Because we went over circles right at the very end of first semester, and you have your x and your y, and they're both squared. So if we think of a circle, and then we think of a parabola, and then if we think of solutions, we could get a whole bunch of different number of solutions, right? If you got a circle, you could have, the parabola that goes through part of it, or, like you got a circle, your parabola could go through this way. Oh, look, it almost looks like, never mind, yeah. You could have a circle, the parabola could just touch one little point on there. You could have a circle, you could have a parabola all the way around and have no solutions. You could have a circle and you could have the parabola going this way, right? So there's a lot of different possibilities to find out these solutions. So if we want to do this algebraically, anybody got any ideas?
Well, why would you do that though?
Because it's fun. It keeps our mind, it keeps our mind working. It keeps our mind intact.
But you can't. Why would you do that?
Do we know what one of our y values are?
Yeah,
Yeah.
x squared minus 13.
Yep.
So you could do that squared.
Yep, we can put in those y's, right? So we're ultimately going to take this guy and we're going to plug it in for just the y, right?
But then squared.
Yep, so x squared, we're just going to write out the original one again, right? Equals 25. Now we're going to substitute y in for y. We're going to get x squared plus, what are we going to put in for y? X squared minus 13. And we're going to square that guy. And it's still going to equal 25. Right? orders of operation, because we got to simplify this. We can't do anything inside the parentheses right now, so we're going to look at our exponent, our square. So we're going to square that baby out. So we'd have
Square
x.
root.
Now we got to take the square of it. So x minus 13 times x squared minus 13, right, equals 25.
So why can't you just do the square root? Right, does that not get rid of the square?
Right, because you have that little plus in there is what's stopping you from being able to take the square root. Yep. So area model on our little guy, right? So what do we got? X squared plus, oops, sorry, minus 13. X squared minus 13. X squared minus 13. What's x squared times x squared?
X.
To the
4.
fourth, right? Because that would be x times x times x times x. Yeah. Minus 13x squared. Minus 13x squared. And what's negative 13 times negative 13?
Isn't it like 169?
Yep. Yep, good job. Positive 169. So going back to our problem, we got our x squared plus, what do we got? X to
X
the
squared.
fourth. Yep, sorry. Yep. Minus 26x squared plus 169 equals 25. Then we're going to look and see if there's any like terms that we can combine. Those-
Your x squared, but you're just going to end up with
Minus 25x squared
yeah.
plus 169 equals 25. Right?
So like,
Bless you. So we can try and get everything on the same side. So we can subtract that 25 over. We have what? X to the fourth minus 25x squared plus 144 equals 0. And this is another, like a perfect square. If I were to write this problem as x squared minus 25x plus 144, would you guys know how to solve that one?
mhm.
Right?
Equals you, right?
So this problem is almost the exact same thing, except for having the x squared, we now have it as x to the fourth. So to get x to the fourth, isn't that just x squared times x squared? Right? Where like on this one, when we were, whoops. If we were to go to factor this one, we would just have x and x. So when we go to factor this guy, what are we going to have? X squared and x squared. Make sense?
Mhm.
Mm-hmm. And then let's see if we can do it without the area model. I'll help you guys out, right? So A times C is going to be a positive 144. So we either got to have positive, positive, or negative, negative.
I just don't know factors of 144 because that's 12.
That's, yeah, I'm going to help you guys out with that one, yeah. So we know we got a negative and a negative. When it comes to figuring out your factors, like, did you guys know this one? Right? And then you're just going to use like your calculator to help you, right? Divide it by 2. Does 144 divide by 2?
Yeah.
Yeah. 72, right? But we know that's not going to get us to 25, right? Try it with 3. Does 3 divide into 144 evenly?
Yeah.
Yeah, what do you get?
Uh, like 50 something.
48.
48? Yeah. Does that get us to 25? No. Does 4 go into it?
Yeah.
What's 4?
36.
36? Yeah. Is that gonna get us to 25?
No.
No, because the sign's gotta be the same, right? Yeah. Does 5 work?
Yes.
What is it? 5 times what?
28.
It does not work.
It does not work, yep. Does 6 work? 6 times,
Yes.
what's 6? 6 and what?
24.
24?
Yeah.
Right, does that get us to 25?
Almost.
No, almost, but not quite. We're getting closer, right? What about 7? Does 7 work?
Yes.
What's 7?
Yes. 24, 5, 7.
No, well, that don't work then. What about 8? Does 8 work?
18.
18? Is that gonna get us to 25? No, but really close. What about 9? Does 9 work? Oops, this thing doesn't show you guys, sorry.
Yes, 16.
16. Does that get us to 25?
I'm confused. Didn't we already pass 25?
Where?
Like, did we actually?
It's when you combine these, you get 25,
Oh,
right? So when I combine 9 and 16, what do I get?
25.
I get 25, yep. So does it matter where I put 9 and 16 on this one?
No.
No, because they are both negative, right? Right. So I'm going to erase some of our little factors just to kind of get this out of the way a little bit, right? So now what are we going to do?
The zero product property.
Yeah, the zero product property, right? We got these two factors. So either this factor's got to equal 0 or this factor's got to equal 0. What are we going to do now?
Well, the x can be 3.
All right, x squared equals 9. Take the square root of both sides. X can equal,
3.
what else?
Negative
Yeah, it can be a positive or a negative 3, right? Good check on that one. If you have a square, how many solutions could you possibly have? 2. So when you get down to here, kind of be like, do I have 1 or do I have 2? Right? Then what am I going to get? X squared equals 16. X is going to equal,
3. 8.
no,
4.
what kind of 4s?
Positive or negative.
Positive or negative 4. Right. So on this one, how many solutions did we have?
4.
4. So when it comes to our little picture, see if I can do it real quick. We would have our circle. Oops. We would have our circle. And then our parabola's got to touch our circle 4 times. So it's going to look something like that. How many times did it go through the circle?
4 times.
4 times. Yep. So when you graph it, it would look something like that.